Thank you. It's true, we're going to get a bit technical, but I will try to keep it at the surface. And if anybody needs some more information about some details, then please ask. So we're going to speak about smart contracts now. And the idea for me would be to kind of do a work on demystifying some of the concepts and making it hands-on so that you can actually know when you're doing an ICO, when you're doing a crypto project, what kind of people do I have to have there, what kind of information will they need, what kind of process, is it normal software, do I have to think about the timeline in a different way, what kind of business models can I actually do with them. This is something that was already touched on this morning, and so I don't have too many slides. If you guys have questions, please shoot. The more the interactive character, I think, the better to deal with such subjects. Okay? It's true, I'm from Define. I have a lot of colleagues. Matthias already did the presentation yesterday. We're very fact-oriented, a lot of mathematicians, a lot of physicists, and so we try to combine complex subjects with hands-on and concrete stuff. We have been working on the blockchain topic for over 2 years. In the beginning, at least for myself, I was very on the B2B side, but my life changed on October last year when I saw the light, the crypto side of the blockchain, and this is what we're going to speak about today, and this is also a part of the work that, that we've been doing with Matthias and David. They're there. We always, when we work in crypto projects, when we work in ICOs, we always come from the crypto side, from the technical side, and propagate our services from then. So we do, I don't want to bother you with this, we do the smart contracts, obviously, which is the thing that we're going to focus on today. A lot of the infrastructure as well, and because we know the details, we can also help at least challenge the concepts that you have thought for your token economy and so forth. So, and because this is about demystifying, I'd like to reach an agreement first on what is it that we're talking about. Because we're not talking about unicorns, we're not talking about angels, we're talking about software that is running on computers, and it's the same software that is running on computers across the globe. And because this software is special, it gives us some guarantees. Now, this is what we call the blockchain. It is a network of computers running compatible software. That's all that it is, nothing more. Obviously, there's a lot to say about the software, and there's a lot to say about what the software does. But in the end, it's just software running, special software running on a lot of computers. One of the very interesting things that the blockchain does, and what this blockchain software does, it's that it interprets code. And the code that it interprets, it's called the smart contract. A smart contract is a program, is nothing more than a program running on these nodes. And this program, what is special about it, is that it's all the same. It's the same code running with the same rules on all of these computers. So that when something is running from your side, you know that you have exactly the same results that I am having, right? So it's deterministic. It runs independently from me if I created the software. It is verifiable. I can look and see what happened. And it has some rules there encoded that might be helpful for encoding business processes, for defining state transitions, And these rules is what is encoded in a smart contract, and these rules is what we're all talking about. So a token is nothing more than a set of rules associated, as we've seen before, with a set of balances. And the rules say only the owner of the balance is allowed to transfer the balance. So only I can transfer my coins. That's what the token contract says. So there's a lot of platforms, there's a lot of different software, blockchain software. We're going to focus on Ethereum today because crypto has been very focused on Ethereum. But I'd like to mention that there's some other platforms, some other blockchain software that is being used that might be relevant in the future and is relevant now. For example, if you think of the pure B2B side of private networks, then, for example, Hyperledger Fabric and Corda have a very strong community behind them. If you think of the past and the present, and for some people, still the future, if you think of Bitcoin, Bitcoin also has smart contracts. They are simple smart contracts, but they are smart contracts. They are pieces of software that define conditions under which you may redeem funds that have been transferred to you. So that's the one. It's called the first generation blockchain. Ethereum is on the side of the blockchains that is called the second generation software that is growing now. That's having also some growing pains like scalability issues, like transaction costs. Now the new kids on the block with different approaches to the whole setup, also with a lot of critique and still not proven as Ethereum has been. For example, Cardano, purely proof of stake blockchain with a lot of correctness guarantees. And also EOS. EOS is also has been launched recently. Sorry. Some problems have been identified with EOS, and there's a lot of critiques as well on how EOS organizes the consensus, how EOS organizes what is correct and what is not in the whole network.
One question. I heard there's something like an update via sidechains that also on the Bitcoin blockchain there will be smart contracts possible. Is that true? And what do you think about it?
I think there's a lot of momentum again around Bitcoin. I think the Lightning Network process has been generating a lot of attention. The fact that it's productive now is also a very good sign. I think the focus of Bitcoin will still remain more on the payment side, and if you want to have something very, very broad-based, then I don't think that Bitcoin will go into this direction. But still, I think it's great news that the protocols are being extended, that we're not staying in a lot of people have been saying Bitcoin will never be because it is now, right? So that people start thinking of what it could be in the future, not staying on the current state. The current state is still, it's still growing. It's just a protocol.
Can I tell something about this?
Please.
It's called Bootstock. That's a sidechain that's already active, so you can already use the smart contract on that sidechain that's related to Bitcoin. But Rootstock says from their side that this is still beta, so they don't want that somebody tries to run an ICO on this, something like that, because it's not proven, but it's still available on the web mainnet. And if you see the Open Zeppelin website, for example, and the complete code you can use on Rootstock too. You find the Rootstock logo that is supported by Open Zeppelin, for example.
Okay. Do you know what the scope is of the smart contract functionality? Do you know what kind of?
That's Solidity.
Just Solidity completely.
That is absolutely compatible to Ethereum.
Okay. So they put an EVM there.
Yeah, this is a sidechain like Lightning. They have the same features as Lightning, plus added the Ethereum virtual machine.
Okay.
And that could be mined by the same miner that's mining the Bitcoin
Okay.
blockchain. That's the main advantage for the miners. It's not a problem to adapt the firmware, for example. There's no one, I think, but it's very easy that both chains are mined, that the side chain is mined to this huge mining power that's already available. So I think from my side it's a better solution as compared to Lightning, but Lightning is already active and has some time advantage. But Rootstock is on the mainnet active too.
Okay. Okay, thanks for the info.
Question, so you mentioned that there's some flaws discovered in EOS. Between EOS and Cardano and Ethereum for a typical ICO project, which would you recommend?
I would recommend Ethereum because that's where the attention, that's where the standards are. EOS is just being launched or is still launching, and you don't. In the end, it's not just about the technology; it's also about where the users are. Where do you have the standards? Where can you recommend? So for me, it's definitely no brainer. I don't know what the traction is with Cardano. I know it's very promising. Also, the way that they structure the project. But if I had to go live now, then it would be clearly I would go with something that has the traction. And that's Ethereum.
So the scalability issue wouldn't be. It's not worth solving that and introducing other risks in your opinion.
Maybe the question is, what do you want to do with the ICO? So if your business model clearly depends on a scalable solution on the short, medium term, then there are obviously some associated risk with Ethereum, right? But there's two sides to the ICO. There's obviously the most important one, which is the one where you have the token and where you do something with the token. And also there's the fundraising, and doing the fundraising on another platform would probably impair the fundraising aspect. So I don't know. In the end, it's a lot of, everything is growing, so you have to project to the time scale that is important for your project with the features that can be there. Okay, so this we've had already. In order to also to understand the current state of smart contracts, I think it's also very important to look at what is currently being done on the Ethereum blockchain and on the smart contracts on the Ethereum blockchain. And I've just tried to compile a list of the applications that I've seen and try to get a feel of how complex they are and what kind of problems they are addressing. So a lot of them is focused on the digital assets. So you have vesting, you have escrow services, you have the exchange. So it's a the decentralized exchange was a very, very interesting topic that is evolving now. And you also have VRC 721, for example, which is a digital asset in itself. And then you have some gaming aspects there, and also, I mean, none of these things are trivial, but I wouldn't compare any of these projects with an actual complexity of the business, right? So, at the moment, we're still in the starting phase. We're trying to figure out the easier use cases with things like games, dealing with the basics of the digital assets, but not much complex logic is being built up there. We still need to progress on this. In order to program smart contracts, one of the usual choices is to use the programming language Solidity. Solidity is very, very special. It is very adapted to the Ethereum virtual machine, which is a virtual machine running on the nodes of each computer that interprets the smart contracts. And there's some very special constraints associated with the Ethereum virtual machine. There's storage constraints, there's computational constraints, and Solidity is very well adapted to these constraints. Also, when you look at Solidity code, it looks very simple. It looks like a lot of things that you have already worked with if you are a programmer. And this simplicity has a positive side, which leads to a certain adoption, a good rate of adoption, as you can see in the curve below, even though there's a lot of noise in the curve. Solidity has been increasing in popularity over time, and there's a very big momentum behind. I don't know, I've heard the numbers, 30,000 Solidity developers and growing, which is much more than can be said, for example, for the other protocols. But at the same time, there's a lot of caveats, because things do not, when you see the code, you expect something of the code, but it doesn't reflect what is happening there. And we will go into this in the last few slides, because this raises some security issues in the end. It has a lot of very interesting features adapted to the use case. Contracts are first-class citizens. We have access to hashing functions, so cryptographical primitives that are the basis of the ecosystem. And there's also some high-level constructs there that help you build your application. Now, Solidity is built with the goal of writing correct smart contracts. So that's the goal of Solidity. It's not building the most performant smart contract. It's not building the shortest set of code. The idea is to have correct smart contracts in the end. So how do you interact with these smart contracts? This is we'll dive very deeply very soon. But in the essence, there's two different kinds of operations that you can do with smart contracts. First, you can ask things. So that's the query. I can ask the token, what is my balance, or what is the balance of somebody else? Or I could tell the smart contract and the whole network, if I broadcast the transaction, please transfer from my account to somebody else's account a certain amount of tokens. Questions? Okay. So let's see. So after there were some questions about investment in the ICO and the token, in the last hour, I tried to build up some mini ICO, the Summer School, Crypto Startup School ICO. And there's two main contracts in this Crypto Startup School ICO. There's the crowd sale, and there's the token. So the crowd sale and the token. The one that you see here is the crowd sale. This is very verbose because we are using a lot of the standards being given for free by OpenZeppelin. But in the end, the amount of code that I wrote is relatively limited. This, and what I'm saying here is I'm defining start point, end point of the ICO, and obviously the most important thing, how can I invest? Now the investment process there's nothing really spectacular about it. There's just a checking, then there is registering, and then there is the most important part for the people doing the ICO, that the funds are being forwarded to some wallet address. So let's try to interact with one of these contracts. I've created one on this mini blockchain on my computer. I've defined some parameters, so when it should start, when it can receive funds, beginning and end, and what the amount range is of the funds that I can accept. So I think Matthias went into some detail about this yesterday on how to structure, for example, a crowd sale contract. and also to where should the funds go to after they have been received by the crowd sale. So this has been deployed. The contract is here. So you can get the parameters. It has started, which is great, and it hasn't ended. Here's the parameters that I put in. Here's the so-called owner, the one that is allowed to do some special operations, and how much I have raised for the moment. Now what I'm going to try to do is to invest in this crowd sale. I need the address of the crowd sale. Sorry. And with one of my fake accounts from my local network, I'm not going to send too much because I don't believe in this project really. So I'm just trying to invest 0.1 Ether. Now what I'm doing here, I'm defining something that we'll be speaking about more in detail is the transaction costs. And then when I've defined this, I will submit the transaction. And as with every live demo, so sorry. So I'm going to define a gas budget. Okay. I was having this problem before. I don't know where this is coming from. So I could invest, but still I would like to try to interact with the token. So the second contract that we have here is the token. And the token is really minimalistic because all the work is being done by somebody else from Open Zeppelin. And I'm just defining here the name of my token, the symbol, and how many decimals it has. And also, the question that was raised before, what is my hard cap? So I can see all these parameters here. And now I will act as the ICO issuer, and I will start minting some tokens. I already have this address prepared here. This is going to be token recipient, and he will just get 200,000 tokens. He has already gotten tokens in the past, and now if you go here, you can see that the balance has been updated. So this is what is being done when you receive the tokens. Somebody is just assigning tokens to your address in the token contract. In this case, I did it on purpose. I could have coupled the investment process with the generation of the tokens. I have not done this because this is what happens a lot when you have, for example, multi-asset ICOs, where there's a lot of conversions, there are bonus calculation processes, and so forth. Okay, questions on this? Cool.
What tools are you using? You are on a Windows
Yeah.
environment,
Yeah.
as I see.
So I have a console.
Yeah.
I was using Truffle. I don't know if you heard about this one. I generated the project, and then I created the contracts. There's the one, there's the other one, and then I flattened the contracts into one file because there's a lot of dependencies, and I've put everything into one file. I copied the file, I pasted it into this browser, Remix, so that I can interact easily with the small Ethereum blockchain that I have running here. This is a small Ethereum blockchain that I could try to kill. And this is done by Ganachi. It's called Ganachi. It's this very local. It's a local Ethereum blockchain that gives you already setup accounts with balances, and it's very easy to use it to do, for example, smart contract testing. That it was called Test RPC. Now it's called Ganachi. They upgraded, yeah. A lot of momentum behind the tools. They're changing all the time. Yeah.
So if you want to build up this simulation, like would you build like a mini ICO? Is there like an instruction online that we can download?
There's a lot of good Medium posts.
Okay.
Yeah. I can put them into the slides and
That'd be great.
in the distribution. Sure.
So the methods, the four methods, transfer, proof, balance of, those are inherited methods.
Mm-hmm. Yeah. Yeah. I mean, there's a lot of reasons why we do this. The code that is being provided by OpenZeppelin has already been audited. People have looked over it. There have been discussions over it, and it's standard functionality. And you shouldn't reinvent the wheel. You should. The more you do by yourself, the more effort you have, not only in coding but also in writing the tests that you need first in order to feel safe to put the token in the network, and also so that also audit costs, etc., etc. Okay. That was it. So when I was adding the balances and I was trying to invest, and when I was deploying the contracts, all of this was performing a transaction, right? I told you about that there's a difference between asking your local node where the smart contract is, what is your state? So how many tokens do I have? As opposed to changing the state, giving somebody some tokens. And when you do this, you're actually creating a transaction and then broadcasting the transaction to the network. When you broadcast the transaction to the network, what happens there? And I'm going to explain this because there's some economic consequences to this. In the first step, the transactions, they go to the people that receive, to the other nodes that receive the transactions, and they go to the so-called transaction pool. If the computer that received the transaction is a miner computer, a computer controlled by a miner, then the transactions will be selected, given some criterion, from the transaction pool, And there will be the computer will try to generate a block where these transactions will be in there. Then the block will be broadcasted, and if, with some luck, it's going to be part of the longest chain, and it's going to be part then of the blockchain, the longest chain of blocks, the blockchain.
Sorry, what do you mean by luck? So there's also no possibility there's not listed there?
Yes, so this is very important. You don't have a guarantee your transaction will be processed. So you can broadcast your transaction, you can even offer a lot of money for this transaction, but it happens that the transaction isn't picked for some reason from the transaction pool, and so you will not be your business will not be processed.
Not big forever or later on?
Forever, it's hard to say, but there are cases of transactions in the Bitcoin network that have been there for 6 years.
For 6 years?
Yes,
Unconfirmed.
unconfirmed, unpicked, yeah.
But
Why?
is it usually not because of the gas is high, then possibility to pick is higher, so there's also other factors.
Yes, so there's no certainty, but you can definitely increase the probability that this will happen by offering more rewards, and rebroadcasting the transaction with more rewards, so that people are aware, hey, here's a good possibility of making money.
So here the main factor is the reward.
The main factor is the reward. It could also be where you are and who are the first people that get your transaction.
There's nothing like the broadcasting, you have to use some skills.
There's no backbone that will guarantee that transaction is being broadcast in some way. So there's really an economic point here about how much is it going to cost me and how fast do I really need it to be processed, the transaction. Exactly.
Quick question. Coming back to the liquidity transaction you mentioned before,
Yeah.
regarding Bitcoin, which is obviously lying there 6 years. Is there any reason for that?
People are looking into this. I don't know.
But when,
There doesn't seem to be. I don't know if there's something special about the transactions by themselves. If they're too big, for example, and therefore too uninteresting or too low rewarded. But the fact is that the system isn't perfect. So, and it's important to know in business that there's a difference between 100% probability and 99.999%. Right. So everyone acts in his or her own interest, and when you think of a lot of us here have the perspective of network users, but if you think of somebody who's trying to make money out of the network, so the miners, they will be looking at the highest rewards, right? They will be rewarded by the network on itself. If they have been able to produce a block, that is being accepted. Ethereum also has a very interesting mechanism of rewarding blocks that get, so to say, demoted. And there's obviously this bit, which is the transaction fees, which are under your control. And this is, transaction fees are paid in Ether, but they are specified in gas. What is gas? A gas is a measure of the computational cost of changing the state. That is the amount of logic that you put in your transaction. The lowest amount of gas that you can pay for a transaction is 21,000, which is just sending Ether across. The more complex the transaction, that is, the more functionality it triggers, the more gas will be required. So this is something that is being determined by the smart contract. What is being determined by you is two things: the gas limit. So you can say, I have a budget on gas that I wish to spend. I don't know the code of the smart contract in depth, but I can say, I'm not going to pay more than a million gas for this transaction. And I can say how much Ether I'm willing to pay for each unit of gas. And so you have a measure of how much using the network actually costs you. You should not forget in any of this when you have your AWS server or when you have your local server, none of this is for free, right? So there are some transaction costs associated with using the whole infrastructure that is being put at your disposal by Ethereum, and this is what it costs. So what is also important to know here is that CryptoKitties have been mentioned. It was, for example, when CryptoKitties were live, it was very, very hard to get transactions through, and it's also very expensive. So from what I remember, the cost of gas to get a transaction through in relatively normal amount of time was 10 times higher than it is now. And this, if you have a lot of transactions, this can make a lot of difference in your budget. So if we go, for example, to my favorite, so when I do the transactions, the place that I go to in order to see what the current gas prices are is the Ether gas station, and they give you an idea of how full the network currently is, what is the current rate of utilization, how full are the blocks, and then also how many transactions per gas price that is being given by other users, and how long they take to confirm given a certain gas price. And so here, every time when I have to do this by hand, I go here, I look at how fast do I need a transaction now, and how much am I willing to pay for it, and then according to these histograms, I just do my calculation and determine the gas price. What is also very interesting about these guys is that they have a model to give some indication. They can give you what is the gas price if you want to have a certain type of confirmation time, what is the gas price if I have to have another more relaxed confirmation time, and what that confirmation time is. And they also publish the code that computes this model, so this is also very useful when we have to do automated transaction placement. As soon as you have more complex business logic, also what you will see is that you will need not only the data that you can get from other smart contracts, but also data that is outside. For example, exchange rates, weather data, if you have an insurance, flight arrival data, because there's some new interesting smart contracts that will automatically refund you if your flight is delayed. And obviously from the gaming side, if you think of casinos, there's some element of randomness that is required. That is very hard to generate within the blockchain, and that you can also outsource. How do you do this? Usually you use an oracle. An oracle is a kind of a trusted third party that will receive some transactions from you. You will say, please give me this data. And this data usually comes in the form of, go to this website and get me this field. And I will pay you something for this. Now, the service provider will look at his own smart contract, will look at the transaction. In this case, we wanted to know the value of X so that we can compute Z, does an HTTP request, gets the value of X, writes it back, and triggers the functionality that you've defined. So in the essence, you have a very elegant way of getting data from the outside by somebody that provides you a service that you have to pay. And that will enable you to not only get data that you, for example, you wouldn't be able to get on-chain, but also data that would be probably very costly to compute on-chain. So any questions on this?
I have learned that the normal code is running on every virtual machine of the Ethereum network.
Yes.
Where standard applies that all these virtual machines make a request to the database. Maybe I come from the old world, and this would be credible. Is the OIC database, the Oracle database, also virtual on all virtual machines?
So the computation it will be doing on demand. So you have your node, I have my node, and somebody else broadcasts a transaction. So we all three agree on what is the content of the next block, what transactions are in there, and in which order should I use them. Yeah. Then there will indeed be. Please bear in mind that the amount of code there is very limited, but there will be indeed a simulation so that everybody has updated their state, so that everybody has the same state version at the same time. So yes, there is redundancy there. Without this redundancy, you wouldn't be able to verify the transactions. But not every computer here will be doing the request necessarily. They would just be looking at the on-chain data. So none of these computers would be doing this service here. They would just be looking at what happens here. So only the service provider will look into the special smart contract that it knows is there and that it owns, and will be doing the request to the outside. But you are right, all the code will be redundantly being computed there. So this is why the concept of gas is also very important, because if transactions were cheap, then we would also be the whole time doing some meaningless computation. So gas has a very important role there, which is to protect the network by making it expensive to attack it.
One question regarding Oracle. So
Yeah.
let's say if you have, you're launching an ICO, you've got a smart contract and proprietary APIs. Would you have to create your own Oracle service provider on top of your API, or rely on some other service provider?
So you can rely, for example, on Oraclize, which is one of the Oracle service providers. And what you would have to give Oraclize would be like the address of the API that you want to call and how it should process the request.
So why not just call your API directly? Oraclize is just going to be an intermediary. Like, what value is Oraclize having?
Oraclize will give you, has the support, for example, for proof of authority. It gives you already the service that it will look into the contract. Oh, state has changed. I will perform a request. So this is already something that is being doing, right? The second thing is that it is a third party, so it's not you. So every other user knows that Oraclize is not you. So there's more trust there. And Oraclize also gives you the ability of doing proof of data authenticity. So for example, providing some TLS certificates. So Crypto Compare is one of the APIs that we use for the exchange rates, for example, also provides the the proof of authenticity. And you can attach this to the result, and everyone can verify that this is indeed the result that came from that trusted source.
Okay. And how do you ensure, since the API is going to be called multiple times
Yep.
in the verification process, how can you ensure that the results of the API is going to be the same?
So the API will only be called once by Oraclize. But Oraclize will get the result from the API, and then we'll write it in the smart contract, and we'll call some functionality. So nobody else is doing this, just Oraclize. Everybody's seeing it because everybody is doing the state updates, but everybody else is just doing the on-chain bit. So there's just one calling the service from the outside.
The first node then that processes the smart contract that will result in that API getting
So this machine here is calling the API.
Right. And
So only the first one.
Only the orange
that's
one.
only start.
Yeah. So this one is calling the API. It's reading what is happening here, and when it finds, oh, there's a request, he sees it, and he calls the API. He gets the result, and then stores the result here, and calls this function. So nobody else is doing this, just Oraclize.
Right, but someone is calling Oraclize to retrieve that data.
Yes.
So it's basically just the first node, correct? The first EVM.
Somebody is saying, Oraclize, please do this. Nothing else. So nobody's calling it, just registering, please do this. It's just a request. Okay.
One more.
Yep.
Can anyone just be an oracle? I mean, how is it quality assured there? Anyone could just use this data.
Yeah. I mean, it costs money, right? Because putting data there costs. But in principle, anybody can do a call to an external API and change something in the chain. You just have to pay for it.
You have to pay
For the transactions, yes.
And then the idea is that it's prohibitively expensive to put bullshit data on the
I mean, why would you put bullshit data if it costs you money? So that's the idea. If it's bullshit data, but you still like it, then you put it there, you just pay the price, and everybody's happy. Yeah. So there's no censorship. Nobody's determining whether it's good or bad. It's just you that's saying it's worth my money to put the data there.
And that's basically excluding the black sheep from even interacting there because okay. Can you give some examples for
Someone that
Oracle?
use your data source. You have to convince someone that he calls your value.
Yeah.
So no one knows that you put bullshit on. So no one cares. You have no advantage, and they have no disadvantage.
Yeah.
And
Exactly.
what are such oracles that are exclusively being pinned or being
Yeah.
used?
Yeah, you have mentioned already an example, the flight delays.
Fly delays, for example.
There's a website, it's called flightstat.com, and they have an API, for example, available,
Exactly.
and then you can connect to this data and then process it in with your contract.
Yeah.
And that's it.
Exactly. You can program an insurance policy on that.
So can I like with a regular private key, just say only I set up this oracle, and the person that can put data into this oracle?
Yes. So you write your own smart contract. You say this is the private key. Nobody else can do with this function. So you require that the person sending the transaction has a certain identity.
And mess around with it.
Exactly.
Data into
Yeah.
this like credible source of data.
Yeah.
But this oracle function is not changing. Like it's immutable. Or I can change it.
What is the Oracle function? So the F.
Yes, that one is defined.
So the F is defined. So the F function is defined by the Oracle smart contract, and the F is usually just saying, here's my URL. Here is what you should do when you give me when you have retrieved the data, and here is how much I want to pay for it.
Okay, but for example, this service is provided where I'm taking the data. For example, after 1 year is not working, and how I can change it? Can I change it?
If you have hard-coded the address of this Oracle smart contract, then you cannot change it. If you have it as a variable somewhere, then you can do this. Yeah. And this is a great point that I wanted to make just right afterwards. Is when you're dealing with usual software, it's a non-blockchain software, and especially in the last years, everything is extremely agile. right? Somebody comes in with a request, and then you analyze it, and somebody just does something very fast, and the deployment is very, very easy. So the step between I wish something and this something happening, technically at least, this is very, very reduced deployment time. And so for example, myself, we have come, we just start doing things, right? You just start doing something. You just build a POC and then an MVP, and then you just go from there. And you know that you are agile and they can change things very fast and along the way as you have more information. Exactly because of the point that you made, for example, if I, for example, decide that Oracle is my provider, and this is the contract that I will always be calling, if I don't think about this beforehand, then I will be having a problem later, right? So, because in the essence, I can only deploy once. Strictly speaking, I can only deploy once. So I will have to change my cycle, and I will have to think very carefully about what I want to do. I will have to test very thoroughly what it is that I have implemented. Does it match with what I wanted in the first place? And then you should also ask somebody else to verify the code for you, because you will be biased if you have done the wish list and implemented it at the same time. And I mean, there's also a lot of things. A lot of things can go wrong if you haven't done your implementation properly, like losing funds because you might be subject to attacks. And so the point that I wanted to make is that it's very important that if you're doing a token, if you're doing an ICO, just give yourself some time to think what it is that I want from the token, what it is that I want from the platform that is going to use the token, and do not write the white paper and publish the white paper first before doing this work on what it is that I really want from the token, because you will not be able to change it afterwards if you haven't validated your ideas. Okay, testing. I will be.
Question.
Yeah.
Is there no mechanism for changing the contract afterwards?
You can put as a logic in a contract that you can change, for example, variables. Okay, and now there are some very interesting mechanisms to put a lot of contracts in place, so that, for example, you have a gateway for your requests, and you can change where the requests are going into, so that you cannot change the contracts that you put there, but you can actually change the logic. So there are currently people developing standards on how you can actually build upgradable smart contracts, but this is very early days, and you have to think this beforehand. So just very quickly, if you want to do tests, you should write unit tests, so that tests the code in isolation. And in Ethereum, you can also have test networks, and you can test your whole business beforehand by putting it, for example, in one of the testnet network. I'm clearly over time. There's a lot of attack vectors, and there's some interesting projects that I would like to highlight on governance, upgradability, as you have mentioned, and very interesting protocols that everybody can use. And thank you.